Okay guys, this is going to be the first one talking about hypothesis testing. Now, this one's not really going to be like, let's answer all the questions. It's going to be much more, what do the words mean that are the basic building blocks of this chapter? And the first one we're going to talk about is the very word hypothesis itself. You might have heard that at lower levels at GCSE as like an educated guess. Well, that'd be more like estimate, to be fair. Your hypothesis is basically what you think is true about the world. It should be falsifiable, as in like you should be able to test whether it's true or false, and it should be reasonable. Okay? Now, you don't really need to worry too much about the actual definition of hypothesis, because we're talking at this level about null and alternate hypotheses, and those guys are pretty well defined. The first one, the null hypothesis. Generally, your null hypothesis is what you'd think would happen if nothing unusual was going on. So imagine for, I don't know, your null hypothesis would be that a Smartie is sweet. Yeah? Because in general, Smarties are sweet. You wouldn't expect them to be salty or vinegary or anything like that. Similarly, your null hypothesis might be that in, say, November, there'll be rain somewhere in the United Kingdom. You'd assume that to be correct. Yeah? So your null hypothesis is generally what you'd assume to be correct, and you generally assume the expected. Now, this sometimes doesn't work as clearly as I've said. So, for example, if you are testing a new cancer drug, the null hypothesis is that it does nothing. Okay? Because you want it to keep the thing the same. You want to keep what's called in Latin the status quo. You assume it does nothing better, in fact, nothing better than placebo, but we're not going to complicate the issue here. So you assume it has no effect. You assume there's been no change. You assume the expected thing that happens is going to be the expected thing. Are you comfy, hopefully, with that? Now, the alternate hypothesis is the hypothesis that tells you about the parameter if your hypothesis is wrong. We'll talk about what parameter is in just a moment. But basically, if you reject the null hypothesis, you get the alternate hypothesis. So let's go. Imagine the null hypothesis is about the cancer drug. The null hypothesis would be the cancer drug does nothing. Your alternate hypothesis will be the cancer drug helps remove cancer cells. Yeah? So it's not quite mutually exclusive with the alternate hypothesis and the null hypothesis, but you generally assume that the null hypothesis is going to say one thing, and if the null hypothesis is false, then your alternate hypothesis kicks in. Okay? Now let's have a look at the population parameter and the test statistic. The population parameter, in this case, and it's not always true for every single thing, generally in this chapter will be the probability for the population. So if the let's say the probability of being male in a population is about 0.48, 0.49, that's your population parameter. Yeah? Because it's something that tells you about the entire population. Now the test statistics is what you're actually going to be researching. So if you were researching gender, for say a sample of 30 people, it'd be the number of people that were male and the number of people that are female. So population parameter is the probability of any individual person of the population having that particular thing. The test statistic is literally what you're researching. Okay? So let's say, I don't know, you want to test, do you want to do a sample of, I don't know, washing machines, and you want to see how many of them are faulty. Your test statistic will literally be, in my sample, how many of my washing machines were faulty. Does that make sense? Hopefully it does. Now, there are two types of tests that you could be asked to do. One's a one-tailed test and one's a two-tailed test. Probably the easiest way to remember these is one-tailed test is either going to say, is it better or is it worse? Does it go higher or does it go lower? You're testing in one direction. Have things changed? Either for the better or for the worse. And the two-tailed test is it different? Yeah? So the example for the cancer drug, you test whether it's better than placebo, whether it's better than a Smartie, or is it better than whatever. A two-tailed test would be, does the cancer drug have a positive effect or does it have a negative effect? So you see there's a difference there. The one-tailed test just tests whether you're either better or you're worse. A two-tailed test, is it different? Okay? If you want a kind of quick clue on this, if you see inequalities, and it doesn't have to be zero, just like inequalities, you're dealing with a one-tailed test. So that's basically for H1. If you're seeing inequalities, you're looking at a one-tailed test. And if you're seeing a not equal sign, you're looking at a two-tailed test. That reminds me, I haven't talked about H0 and H1, so I'm going to go back and do that. Okay, so I said I'll talk about H0 and H1 just for a moment. H0 is the code for the null hypothesis. H1 is the code for the alternate hypothesis. H0, if you see that, you're talking about null. If you're talking about H1, you're talking about alternate. Okay? Right, let's finish this. So how does this all work then? Yeah? How does this work? Well, we talk about two things. We talk about significance level. So here, generally, significant level are things like 5% or 1% or 10%. And basically the idea is, when we do our research, if the thing that happens is so unlikely, yeah, that it only would happen 1% or 5% or 10% or whatever is specified as a significance level, we reject the null hypothesis. And then we take up the alternate hypothesis. So it's kind of counterintuitive. We always sort of believe the null hypothesis is true at the beginning, then we test to see whether it's not true. And the way we do that is by saying, if what happened in real life, so if our sample throws up results that would only happen, say, 5% of the time if the null hypothesis is true, then we're going to say we're going to reject the null hypothesis and we're going to stick with the alternate hypothesis. Notice, like, you've got to be very careful with the word proof there, yeah? It doesn't prove the alternate hypothesis is true. It doesn't prove the null hypothesis is false, right? Because things that happen 5% of the time happen 1 in 20 times, right? So that's still something that could potentially happen. All it's saying is that there's enough evidence to say we're not going to believe the null hypothesis is likely. We'd rather go with the alternate hypothesis that's much more likely. Okay? Very, very hard to prove anything in statistics, especially in this kind of chapter. Okay? So be careful when you're using the word prove. All you're going to be able to do is reject the null hypothesis or accept the null hypothesis. And if you reject the null hypothesis, then you are forced to accept the alternate hypothesis. In that case, it's almost like a mutually exclusive. If one thing doesn't happen, the other thing does. I'm not sure how effective and useful mutually exclusive is as a kind of thinking tool here, but that's the way it works. I hope that all makes sense. It's a bloody long video, this one, 7 minutes and so. So I'll talk to you later. We'll actually take you through some examples. Hopefully that does clarify what the words mean. Just go back to significance level. It's it's your probability that you're testing. How unlikely does the result have to be for you to reject the null hypothesis? And literally that's the words I've said there. And rejecting the null hypothesis means we're accepting the alternate hypothesis. So we're saying whatever we chose as a null hypothesis is not what we're going to believe anymore. We're going to believe in the alternate, but it's not quite proof. Okay? Thank you very much. Bye.